Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we'll be looking at the modeling of exponential growth and decay. Now, the easiest thing to do is to go straight into an example. There isn't really any new theory in this lesson, and things should become very clear as we work through an example together. And the example in this case is about an oven. The oven is turned on at 12 noon. And after m minutes, the temperature of the oven is given by the formula T equals 225 minus 207 e to the power of minus m over 8. Now we're asked to do 5 things. First of all, we're asked to find the initial temperature of the oven just as it's turned on. Then we're asked to find the temperature after 5 minutes to the nearest whole number. Then we're asked to find at what time the temperature reaches 190 degrees centigrade to the nearest minute. Then we're asked to make a sketch of the graph of T against M. And lastly, we're asked if the model suggests that the temperature of the oven will just keep on rising indefinitely. Okay, I'll let you have a go at this question yourself first. So pause the video, have a go, and then come back to me again when you're ready. Okay, let's have a look at this together. So the first thing we're asked to do is find the initial temperature of the oven. And on these types of questions, frequently this is what you're asked to do. Now, the initial temperature is when the number of minutes is equal to 0. So it's when m is equal to 0. We just substitute that into the formula. That gives us T equals 225 minus 207 times by e to the power of 0. Anything to the power of 0 is 1. So that is just 225 take away 207, which is 18 degrees centigrade. That's the initial temperature of the oven. Sometimes in questions, they might ask you to find the room temperature. Now, that would also be the room temperature. It's the temperature that the oven is at before it's turned on. And that will just be the temperature of the room that the oven is in. Second question asks us to find the temperature after 5 minutes to the nearest whole number. Well, the number of minutes is m, so we just have to put m equals 5 into the formula. Putting in m equals 5 will give us that. Using the calculator, e to the power of minus 5 over 8 is roughly that decimal. Multiplying those together will give us 110.799, which gives us 114 degrees centigrade to the nearest whole number, which is what we were asked to do. The third question asked us to find at what time the temperature reaches 190 degrees centigrade to the nearest minute. Again, just go back to the formula. Now, this time we've been told the value of T. We've been told the temperature. And we want to know when the temperature equals 190. So we just substitute 190 in for the temperature. Then moving things around will give us that. And then we've got an exponential equation where the power is the variable. If ever you have any sort of exponential equation where the power is the variable, you will have to take logs of both sides of the equation. Now, you could take the log of any base, and it will work. I'll choose to do log to base e because e is in the question, and that's likely to make it a little bit easier. But you could do log to the base 10, and you would still get the right answer. So taking logs of both sides would give us that. And then, a bit like we did in the last 2 lessons, we can split this term up using the law where you have 2 things multiplied together with logs. And that'll give us the log of 207 plus the log of e to the power of minus m over 8. We can then use the law for when you have powers and logs to split up this middle term, and you'll get log 207 minus m over 8 times by log of e, which is log 35. Moving things around gives us that. And then the reason why I chose to do ln log to base e is because this sort of thing was likely to happen. Log and e are inverse functions, they cancel each other out, and they will just equal 1. Log of E is 1. So swapping things over, that gives us m divided by 8 is equal to log 207, take away log 35. Multiplying both sides by 8 will give us that. And at this point, I would just put everything into the calculator. That gives us m equals 14 to the nearest whole number, to the nearest minute, which is what we were asked to do in the question. Now, the question didn't ask us how many minutes it would take for the temperature to reach 190. It asked us at what time the temperature reached 190. So we need to remember back that the oven was turned on at 12 noon, and it's taken 14 minutes for the temperature to rise to 190 degrees. So the time when the temperature reaches 190 degrees is 12 noon plus 14 minutes. And that takes us to 14 minutes past 12, 12:14 p.m. Now the fourth question is a little bit tricky. They ask us to sketch the graph of this exponential function, but it is a complicated exponential function. The first thing is that t will be like y, it's the dependent variable, and m will be like x, the independent variable. So t will go on the y-axis, and m will go on the x-axis. I would not try to sketch all of this in one go. I would build it up step by step, because it's quite tricky to do it all in one go. Doing it slowly and carefully, first of all, I would just sketch the exponential part, e to the power of minus m over 8. E to the power of minus x always looks the same. It doesn't matter what you have here. It'll have that sort of shape, where it goes through the y-axis at 1 and then gets smaller and smaller and smaller, heading towards the x-axis. Now, normally it would carry on this side to the left, rapidly getting bigger and bigger and bigger. In this instance, it doesn't, because m is the number of minutes after the oven has been turned on. Well, the least that can be is 0. M cannot be a negative number in this question. So for us, the sketch of the graph will begin at m equals 0, the moment we turn the oven on. Now, the next thing I would do is bring in the 207. 207 times by e to the power of minus m over 8 is a stretch in the y direction. It stretches the graph vertically with a scale factor of 207. It won't look very different, but this point here will get stretched all the way up to 207. And you get something that looks a little bit like that. The next thing I do is deal with the minus in front of the 207. Minus 207 e to the power of minus m over 8 will reflect the graph in the x-axis. So this graph is going to flip down as it reflects beneath the x-axis. Plus 207 is going to reflect down to minus 207. And you get something that looks a little bit like that. Then we need to put the 225 on the front. Now, if you have 225 take away 207 e to the power of minus m over 8, it's slightly easier to see what's going on if you just swap these two terms over and write it as minus 207 e to the minus m over 8 plus 225, which is a translation vertically upwards in the y direction by 225 units. So the last thing that needs to happen is that this curve just needs to be shifted upwards, translated upwards by 225 units. Two things are significant. The first thing is this point on the y-axis, which is going to move up 225 units, and that'll take it up to plus 18. But the other thing that matters is the asymptote. Up until now, the asymptote has been the x-axis. Well, the asymptote is also going to move up 225 units and become the line y equals 225, or t equals 225. So after the translation, 225 upwards, you will have something like that. Where, as we said, this point on the t-axis is at 18, and the asymptote has moved up. And you do need to sketch the asymptote when you sketch the graph. That would be the completed sketch. Now, the last question asks us, does the model suggest that the temperature of the oven will just keep on rising indefinitely if it's turned on forever? Well, the answer to that question is no. And it's the asymptote that tells us that. The temperature does keep on going up and up and up and up, but the rate of increase gets smaller and smaller and smaller. And it never actually reaches 225 degrees, but it does get closer and closer to it. So no, the answer is no, because there is an asymptote at T equals 225 degrees centigrade. This is the maximum temperature that the oven can reach. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 117 and have a go at exercise 5E. Thank you very much for listening, and cheerio.